So this is our notes on inverse trig functions. We touched on this topic before the break. By the time you get to this step in the video to go through the lesson and take the notes, you should have already completed your theta, the Thanksgiving turkey page from that Friday before the break, and done some of those practice problems on that worksheet you got that Friday. If you have not, don't forget to go back and do that. So here, if you don't have this, what you're looking at here that says Unit 4, Building Block 1, Part 1 notes, you need to get this. The sub has this to pass out. Okay, so this is what you should have in front of you, hard copy, following along on to take your notes. So we need to recall that functions only have an inverse, okay, or a function has an inverse if and only if it is if it's 1-to-1. Where did hold on, my pen, of course, now that I'm recording, this stopped working. There it is. Okay. All right. One. Why is it being sloppy? I hope it doesn't do this the whole video. So if it's 1-to-1, remember that means that every input has only one output. That means there's only one y value for every x value. Okay, we kind of refreshed on that the Friday before break as well, when I was showing you that the inverse would have to pass the horizontal line test. So that means that the original function would have to pass the horizontal line test. So you can see here in this graphic showing the sine wave, okay, it would pass the vertical line test, okay, but if I were to turn this on its side and this wave were to continue like this, it would fail the vertical line test. So that's where these restrictions, these red dashed lines restricting it, come into play. Because if I stop it here and here, then not only does it pass the vertical line test, it also passes the horizontal line test. So that means that when I do the inverse of this piece, this restricted section, okay, it looks like this, and it will pass the vertical line test so that it is a function as well. So we talked about where we restrict that. We know that on the graph of the sine function, it goes through the origin, and then it gets to its high point at 1. And if you need to think about the unit circle to know these points, you can think about it. When you're going around the unit circle, it's at pi halves or 90 degrees that sine is 1. That's the top of the circle. Okay. And back around the unit circle, if you are on the negative part of the y-axis, which if you're going in the positive direction, that is at 3 pi halves. That would be here. Okay, you're at -1. Okay, but we're going to go backward to get to that same point. So backward, and that means a negative angle, it's negative pi halves. And the reason we're going to do that is because we couldn't start from here and get to here and still pass that test, because here these points would fail the horizontal line test. So we don't go in the positive direction to get there because we'd have to hit some repeated values. So this is like quadrant 1, quadrant 2, 3, 4. That's that one cycle. Okay, but we have to go backward to get to that low point. So it's quadrant 1 and then going backward into quadrant 4 if you were sketching an angle. So this is where the inverse sine function is going to exist. But remember, x and y switch when you do an inverse. So here in the parent function, in the sine function, your domain is negative pi halves to positive pi halves. and the range is -1 to +1. But when we flip that, now it's for the inverse function, the domain is -1 to +1, and the range is -π½ to +π². And you could see, like, if this continued, it would come in this pattern here. It'd be that wave going vertically instead of horizontally. Okay, so that's pretty much the gist of what this paragraph up here is saying. It's talking about how we have to restrict it so that it is a function. Now, some terminology that's new is we've seen inverse written with the -1 power. Okay, that's how we've written all inverse functions. That's not new. So you can write inverse sine of x this way. Okay, it can also be written as arc sine of s. So let me see. I thought that was up here in this paragraph, but now that I'm looking over it, I don't see it. It must be, oh, it's down here that it talks about it. So writing it this way, arc sine of x means the same thing as inverse sine of x. So we can actually, the way that you read it, just that piece would be arc sine. Okay, and then that's how it's written as an equation, y equals arc sine of x. Okay, so that means the same thing as this right here, inverse sine, arc sine. Those are synonyms, meaning the same thing. All right, so we're going to go ahead and fill in that domain and range that I just mentioned. So we said for the parent function, for the original sine function, the domain, the restricted domain we're talking about is from -π² to +π². And it includes those points. Those are included. So we would use brackets and interval notation. Okay, the range, -1 to +1, low to high. And again with brackets. Now, the inverse, when you flip those, x and y switch. So the -1 to 1 becomes the domain, and the -π² to π² becomes the range. All right. Now, we also need to remember that your inverse relationships between trig functions, we can use those to find acute angle measures. Now I say acute because our answers, our output, okay, is going to be an angle. So you're going to input a trig value. Okay, your output's going to be the angle. When we were dealing with the regular trig values, we input an angle and got an output of the trig value, of the exact trig value. So that's switching. Our input and output have flipped. So our output's going to be an angle, but the angle has to be between these two values.